they can be performed directly on the 16 bits. Same thing if you are doing in 8085 processor, then it will take long time. If you write the program for for addition of 216 bits, then you will have number of instructions in that program. Whereas in this case, at a single stretch, all the 16 bits can be manipulated. So that is how the execution speed of 8086 is increased. Further, the memory also is increased in 8086 processor. Now, depending upon the address lines, the memory is also decided. If you are inserting extra memory, that is a different issue. But as such, depending upon the address lines, the memory also will be decided for that particular processor. Now, if you recollect, 8085 processor had an address bus of 16 lines. So address bus was 16 lines or 16 bits, whereas in 8086 processor, the address bus is of 20 bits. So by now you must have understood that the data bus is 16 bits, address bus is 20 bits. Now the memory is decided depending upon the number of lines in the address bus, I said. So in this case, the total memory will be 2 to the power of 20, which will be 1 megabyte. Whereas in the case of your 8085, it was 16 address lines. So the memory was 2 to the power of 16, which was 64 kilobytes of memory. So now you see that the memory size is also increased in 8086, as well as the execution speed is also increased. Now by execution speed, you can also recollect that the number of machine cycles which are needed will be less if the execution speed is more. So compared to here, see, the comparison is between 8085 processor and 8086 processor. Further, the next advanced version is, which you are also having in your syllabus as the last block of your material, 286 processors, 386 processors. Those are again little bit advanced versions when compared to your 8086 processor. Now, further, one more major point which is to be noticed in 8086 processor is there the working registers which were available were only 8 bits wide. Working registers, if you remember the block diagram of 8085, working registers were your register B, C, D, E, H, L. If you use two registers together, you could use 16 bits of data at a time which could be manipulated. In this case, directly the register is given as 16 bits. You also have an option of using individual 8 bits also. Like you can see the EU unit in the figure, EU, execution unit in the figure. There you will see you are having registers AH, AL, BH, BL, CH, CL, DH, DL. So if you are using both the registers AHAL, it is denoted as AX. Similarly, if you are using both the registers for 16 bits, it is BX. So like this, 16-bit register is available. 16-bit register you will denote it as AX, BX, CX and DX. These are the working registers. But if you want to use only 8-bit of that particular register, then you are denoting it as AH, AL. Similarly, for B register, it is BH, BL, and C, it is CH, CL, D, it is DH, DL. Now further, if you see in the figure, you will see SPBP. In 8085 you had a stack pointer. Here there are two stack pointer registers which are 16-bit wide, and SP is your stack pointer, BP is your base pointer. Similarly, you are also having other two registers which are SI and DI. SI and DI, these are index registers. We will come again to this point once again. Simply you observe the block diagram here. So the block, the dotted block represents the processor, and this processor is interfaced to the memory. At the top left corner, you can see you are having a memory interface. So from where the to and fro motion of the data, that is the input and output of the data, will take place through your memory interface. Then in the block diagram, you will see to the extreme right, you are seeing instruction stream byte queue. So instruction stream byte queue. It means that at a time 6 bytes can be kept ready for operation in your processor. Now, one more point which increases the execution speed of the 8086 processor is pipelining technique. Now, what you have learned in 8085 is every time an instruction will be fetched, decoded, and executed. So this was what happens when you fetch an instruction. It is fetched, it should be taken into the processor through your address bus and the data bus. So address bus will point to the location in memory from where the 1 byte of data has to be taken. By data, we don't mean that it is only a numerical. It could also be the opcode of an instruction. So the address bus will only point to the location from where the data is to be fetched. Afterwards, the data is placed on the data bus. So there, only one at a time, the instruction will be fetched, decoded, and then executed. Here, the pipelining technique will do something what is known as multitasking. How it will do the multitasking is, the instruction, once it is fetched by the BIU, bus interface unit, the execution will be done by the execution unit. So while the execution unit is doing the execution, in that time, another instruction can be fetched by your BIU. So that is pipelining technique. So at a time, you can say that fetching will be done by BIU and execution will be done by EU. So the moment EU is doing the execution, the BIU will fetch another instruction. Again, it will push that same thing to your execution unit. So like this, the process will take place and the speed of execution is also increased. So you see there are certain improvements which has taken place with the technology to increase or to give an advanced version of the processor from 8085 to 8086. Now, in this, you can also see you will have same within BIU. You are also having what is known as segment memory. So on the right side, you can see there are some segments. Segment register also you can call. That is ES is extra segment, CS is code segment, SS is stack segment, DS is data segment. So there are 4 different segments in this case. And then you will also have IP, that is instruction pointer. So instruction pointer will keep track of the next byte in the program, just as your program counter used to do in your 8085 processor. Now, control system will control the operations of each block. Arithmetic logic unit is same as you have seen in 8085. It will carry out all the arithmetic and logical operations. And then one more important block here is operand flags. So in 8085, you had one flag register. That flag register, which was 8 bits. Here your flag register is again of 16 bits. There the flag register was 8 bits, and whenever the operations are performed, the arithmetic and logical operations are performed, the flags will change its status. That is what you know till now. So now slowly you will see what are the different flags in the 8086 processor. The 16-bit, which I said, the same earlier like 8085. Here also you will have sign flag, parity flag, auxiliary carry, carry flag, and some bits will be left vacant also. So this is roughly a rough sketch about the flags. Now you are seeing some shadowed lines, thick shadowed lines. Those are all buses there. So you can see address bus. If you remember from your previous knowledge of 8085 processor, address bus is only, it is a unidirectional. It is only going from the processor to the memory to point the location from where the data is to be fetched. So it is unidirectional address bus, whereas your data bus will be bidirectional. So you are seeing some lines, they will be unidirectional, some will be bidirectional there. So if it is bidirectional means input and output from that particular block will take place. That is how it goes. So to enlarge that figure and all, only that figure part I have taken on this page. So far what all points which we have seen is the arithmetic logic unit is 16 bits. Why I am saying arithmetic logic unit as 16 bits? Because the 16-bit data can directly be manipulated, or it can, any arithmetic and logical operations directly can be worked on the 16-bit. That is why you can also say that the arithmetic logic unit has 16 bits. So the operation speed has increased. Then, as I already said, 16-bit of data bus exists. So it can transfer 2 bytes of data in one machine cycle. So machine cycle will determine the execution time of any instruction. So similarly, a program which is having some instructions within it, it will also determine or tell you how much time the program takes to run. So it depends upon the machine cycle of the particular processor. Now, just now I said it has got 20 bits of address bus. So the total memory that can be interfaced to the processor will be 1 megabyte. Now, as you have seen in the block diagram, there are 2 separate units. So the whole architecture itself is having the 2 hardware units: bus interface unit, which is BIU, and execution unit, which is EU. Pipelining facility exists. So multiple instructions can be executed in parallel. So when I'm saying that the BIU is fetching the instruction and EU is executing the instruction, it means that parallel operation is being done, or it is doing something similar to your multitasking. So the parallel operation is also increasing the execution speed of the processor. Now here, just now I also said working registers, which you call them as general purpose registers also, actually being 16 bits. There are 4 general purpose registers. 4,16 is written. It means that there are 4 16-bit general purpose registers, and If you are saying you are having 4 16-bit general purpose registers, then you have to denote it as AX, BX, CX and DX. Then I also said there are two 16-bit index registers in your block diagram, two 16-bit stack pointers, that is SP and BP. Now, it also supports memory segmentation. See here, memory segmentation means that total memory can be divided into segments, and the segments are given the name code segment, data segment, extra segment and stack segment. Flag register is 16 bits. Now, one more feature in this 8086 is 1 megabyte memory is bisected into two banks. Lower bank consists of even addresses and higher bank consists of odd addresses. How it will work, I will show you later this part. But for now, you can also, you simply remember that the total 1 MB memory, it is divided into 512 kilobyte and 512 kilobytes. And the lower bank has got all the even addresses and the higher bank has got all the odd addresses with it. So all this which I have been telling you is all, just now what all I said is all written in this same thing. Now we will see what is the function of your BIU and EU. So the fetching part of the instructions will be done, like interfacing with the IO devices will be done by your BIU, that is bus interface unit. So it is responsible for establishing communication with external peripheral devices. So bus interface, from that word itself, you can understand that it is communicating with the other IO devices or with the memory which is needed for your execution of a program. So the purpose of BIU is to fetch the instruction from memory. Now, fetching the instruction means it is reading data from IO devices as well as from the memory. Then if some program output is to be seen, then it will do the writing into the IO or memory devices. And it also provides the address relocation facility. This address relocation facility, how it is doing the relocation part, that is also one particular feature of this 8086 processor. So this address relocation is done as per the memory segments. I showed you in the EIU towards the left, you are having memory segmentation as extra segment, code segment, stack segment and data segment, that is ES, CS, SS and DS registers. And we can scale the address and the physical address. There is one small relation for this, how to find out the physical address, that we will see little later. So now your BIU, see when a question is coming in the on the 8086 architecture, you can draw the figure and then you can individually, you can first give the details of address bus, data bus and the control bus, and then you can also write about the pipelining feature, and then you can also say how the execution speed is increased, and then you can come and describe the blocks BIU and the EU blocks. So that will finish the description of the architecture of your 8086. So now as you can also see that BIU has three main parts: segment registers, you have seen in the block, the instruction queue and instruction pointer. Now, what is it that each block does? Each block, instruction queue, as you have seen, it prefetches, means initially only it will fetch and keep those instruction bytes in advance from the memory. And two-level pipelining is, fetching is done by BIU, execution will be done by the EU. So simultaneously the two works will be taking place. That is why it is two-level piping it is called. Now the prefetched instructions, they are stored in a group of high-speed registers. It is only given some name that prefetching means you are getting them before the execution of the instructions only, because in 8085 once it is fetching, it will decode, execute, then only the next fetching will take place. Here it is not like this. So that is why it is said that the instructions are prefetched and they are stored in a group of high-speed registers known as instruction queue. Instruction queue register, which you have seen in the block diagram also. Now, these after fetching, what order do they follow? They follow first in, first out order. So this you must have come across this word also. FIFO is first in, first out order. So whichever instruction is saved first, that will be executed. It will go first and it is executed. They work in parallel. BIU and EU work in parallel. Now, the simultaneous operation, the same thing which I kept telling you all the time, the simultaneous operation of BIU and EU is possible only when EU will not require the system bus. Now, see here, what this means is EU will not need the address bus. Only the BIU will need the address bus to prefetch the instructions. So, that is how the EU is parallelly working with BIU. So it will not require the system bus. It is simply doing the work of execution. So it doesn't need the system bus. Now the process of fetching the next instruction, what is meant by pipelining is the process of fetching the next instruction in advance while the execution unit is executing the instruction, current instruction is known as pipelining. So due to this, your 8086 processor will has a larger speed when compared to your 8085 processor. Now, the other block in your BIU is your segment register. So, in the 20 address lines which we have seen, this one point is little different, which you have to notice. The 1 MB memory, which can be available with your 8086 processor, it is bisected into 16 local segments. What you are seeing in the figure is only 4 local segments are shown in the figure, and each local segment, it is of the capacity is 64 kilobytes. So all those short forms which you are seeing, that is CS, DS, stack, SS, and ES, that itself, each being of 16 bits, and the size of each memory segment being 64 kilobytes. So like this, you can have 16 local segments, of which only 4 are there in your architecture, which is seen there. Now, what these segments will do is, they will identify the physical address of the memory. Now, for calculating the physical address, the relation is physical address PA. PA is equal to segment register address multiplied with 10H plus the this is another one more pointer, offset pointer. OP is your offset pointer. That will give you the physical address. For this also later I will show you one example how this physical address will be calculated. Now this is regarding that segment register only. 2-3 points you have to write about that block. So PA, physical address, is segment register address. There are different segments. So naturally the segment register address will also be different. That is multiplied by 10, and to that it is adding the offset pointer address. Now, so these registers, they are used for accessing data very fast. Now apart from your segment register there, your execution unit, So in your block diagram, you are having a segment register and then instruction pointer is also there in that. Now, what does the instruction pointer do? As the name goes, it will hold the address of the next instruction, which is to be executed. And it also contains the offset value of the next address. Now, all this is only to describe what each block is doing in your block diagram. Now coming to the execution unit there. So in the BIU, instruction stream byte queue and segment registers and instruction pointer were the three major things which you have to see and what is the function which they are performing. Next is your execution unit. In the execution unit, you are having three blocks there. And first of all, what the execution unit does, it performs the BIU, it informs the BIU from where the next instruction or data is to be fetched, because it is doing execution. Once it is over, then it should get the next instruction which is to be on which it has to execute. So it will inform the BIU that from where it has to take the next instruction, and the EU performs the functions of picking up the instruction from the instruction queue of BIU. It decodes the instruction and executes them. It updates the status of flag register. It is updating the status of the flag register because arithmetic logic unit is there within the execution unit only. So that is why the one of the functions of execution unit is to update the status of the flag register. Now in this in the EU, you are having a control unit block also. It controls and coordinates all the activities of the subunits. It fetches, decodes and executes the instruction, and it gives the control signals like read, write, etc. So obviously reading, writing and then updating the flag register, all these are the control operations. So somebody is controlling the total operation of your 8086. So that is why the control unit is present with your execution unit. Now ALU, as I already said, that it performs all the arithmetic and logical operations, and the results are stored in the general purpose register or index registers. So earlier also you could store the result in 8085 also in the general purpose register, or you can store it in the memory locations also, provided the address of the memory location is given. Now here also there is a possibility that you can save it in the memory location also, but since we are now discussing about the execution unit, you can as well say that the result is stored in the general purpose register also. Now arithmetic logic unit updates the flag register after every instruction, but the command will be with the control system, and depending upon the command from there, the flags in the flag register will be updated. Now next is general purpose registers and pointers of EU. This we have seen already, general purpose registers of general purpose registers already I told, it is AX, BX, CX and DX. Now if you have to use individual registers, you can use them as AH, AL, BH, BL in that way also. So these registers, your general purpose registers, they are used for accessing the data very fast. Then other than the general purpose register, in the block diagram, you are also having SP, I said, stack pointer and base pointer, and then you are also having index registers, that is SI and DI. So the DI is used for data, and the index registers, that is SI and DI, it is used for the data and the extra segments respectively. So SI will be used for your data segment, and DI is used for your extra segments. So your extra segment is your ES in the BIU block, and data segment is your DS in the BIU block. So this much you have to mention about your architecture. Now, one more thing which we have to. So far I think everything was clear for you.
Excuse me, ma'am.
Yes, yes.
Ma'am, if question is there in the exam, we
Yes.
supposed to draw this full diagram, or
Yes, yes.
separate programming models are there that we have to write, or this?
Programming model, there is no programming diagram. In your material, if you are having with you now, you can see the architecture of 8086 processor. That same thing you have to draw. Maybe you will feel that
Yes,
is
sir.
more easy for you. If anybody is having with you the material beside you, you can just see that that same figure. I have put it horizontally. In your material, it is vertically given. And other than that, here initially I have discussed about the features of 8086, how they are different for 8086 from 8085. So in the exam you need not have to write about the features, directly you can draw the block diagram and go with the description of each block there. That also you can do. So I think you are talking about the programming model from your material only, because I
Yes,
am
ma'am.
also.
Nothing but
But
only explanation of architecture of
no,
88.
no, you should not put the programming model. Programming model is only showing you how the individual registers are there. Architecture means you have to give this
Yes,
block
ma'am.
diagram only. It is a
Okay.
block.
Program, function execute and pipelining, right?
Please repeat. It is not clear for
Ma'am,
me.
it is in figure number 16.3. There is a pipeline architecture allowed fetch and executive
No, no
overlap.
need,
This was
no need. See, if you are getting any short question, like write about the registers of 8086 or write about the pipelining technique of 8086, then only you have to draw that pipelining figure and write what is pipelining
okay.
and how pipelining is increasing the execution speed of your 8086 processor.
Okay.
Okay, ma'am.
When a short question is coming on this, or if they may ask that how is 8086 a advanced version of 8085, then you can give under that these points. If a question directly arises on the pipelining feature of 8086, then you draw the diagram, explain what is pipelining and how it is increasing the speed, then only. Otherwise, architecture means this figure only which you are seeing on the screen, that only you have to draw, or whichever is available in your material, that itself you can draw. And here there are things which I have put under separate headings, but the material which is there in your textbook also, it is very clear and very easy to understand also. That also you can write for your architecture part.
Ma'am, this question is for 5 marks, or LAQ we can expect?
All the architectures, all the block diagrams will be long answer question only. They will not be for short answers.
Yes, ma'am, and
Okay, ma'am.
repeated for every year.
Oh,
Architecture.
And then even if they ask you the pin diagram also, since 40 pins are there, you have to discuss one by one about each pin there. And then here one more point which you have to notice, or you might have noticed, is address bus is 16 bit, address bus is 20 bits, and data bus is 16 bit. Now if you compare this feature with your 8085 processor, there you had 16 bit of address bus and 8 bit of data bus, and the 16 bits of address bus, in that 8 bits are multiplexed, time multiplexed data bus, means the out of the 16 address lines, lower address lines are used for as data lines also. Time multiplexed means for some time they will be used as the data bus, and for some time they will be used as address bus. So when it has to be used as address bus, your address latch enable will have two states, 0 and 1. So depending upon the state, that lower order address bus will be used either as address or as data. The same feature is also existing with 8086 processor also. Here also you are having address latch enable in the pin diagram. Depending upon the state of the address latch enable, your lower order address bus will be, here it is the address bus being used as data bus or address bus. Now address bus 20 lines means 16 are already doing the double work of even carrying the data. Did you understand this part? Are you understanding? 8085 processor, you had AD0 to AD7. AD means
Yes, ma'am.
it is used both as address line as well as data line. Here in 8086 also, from AD0 to AD15, the address lines can be used as address or data. And the other 4 lines are used for some other purpose. In this case also, it will be like that only. Okay, the pin diagram.
Okay, ma'am.
Check whether the pin diagram is there in your material. Otherwise, I will have to give. Because in the book which I am having, like I am comparing your material also with what I will be telling here. Check whether you are having the pin diagram.
In unit 18, page number
Page
254.
254 or 255. Here there is no diagram, but in your book it is
Empty
there.
paper.
Then I will have to give that pin diagram, but that will be in the next class only. And that I square L which you have asked, I have seen, but I couldn't put it on the screen, or maybe I will draw and post it in the group only.
Okay, ma'am. That will be useful.
Now coming to the flag register. It is not there here. You can also refer to the material if you are having. So you can check there the lower 8 bits. The lower 8 bits, these are the same flags. Sign flag, zero flag, auxiliary carry flag, parity flag. So, and then apart from that, you are having 4 status flags there. So what you have studied for 8085, the same thing, and added to that, you will have the 4 flags, that is TF, IF, DF and OF. So TF, see there, TF, it is a single step flag. Now in the C programming, I don't know if you have, anybody has done that C programming. When you execute the program, it will give errors line by line. If anybody is there in the class who knows C language, so line by line it will check. In this also, I don't know whether you have done in the lab or no. You can check your program step by step, each instruction. So single step checking feature is there with your 8086. So that is with your TF bit of your flag register. So single stop flag, when it is set, a single step interrupt occurs, and after that the next instruction executes. TF is cleared by the single step interrupt. So for this also, in a little different way, if you see when there is a carry, the carry flag is 1. When there is no carry, it is 0. This you have seen already in your 8085. I don't know whether I have discussed that similar pattern in the class. I don't remember now. Generally, I will give that way only. Similarly, parity flag also, when it is 1, what happens? When it is 0, what happens? Like this, the same way for your TF, and then for IF, interrupt flag, single step flag, DF is direction flag. So these are small things only, because they may also ask you, discuss about the flag register of any processor. So whether it is 8085 or 8086, you should know that how the flag register behaves, and then that is to be discussed in your answer when you are talking about your flag register. Now similarly, DF, direction flag, and OF, overflow flag. So the bit position is given in one of the columns, name of the flag is given, and what is the work of that flag. So straight away, if you are able to put that 16 bits, so you can see in your flag register, the higher 4 bits, they are not used. So that is why it is XXX. So out of 16, only 12 bits are operational in your flag register. So in your material, they have given some examples they have taken, and they are seeing whether that particular, suppose if it is parity flag. So how many number of ones are there? The parity flag will be 1 when the result is even. It has got even number of ones. And if it is odd number of ones, then it is equal to 0. So that they have shown by a numerical example. For you, it is not needed to show it by a numerical example. So I think I will also give it little more clearly for you so that you can remember it very nicely. Similarly, sign flag. So a sign flag also, if the result is positive, then it will be 1. If it is negative, it is 0, like this. If there is an overflow, then the bit will become 1. That is how the arithmetic and logical operations result after they are execution. The status flags are affected. That is what is one of the points which is written in the material in this. Now anything more you want to ask, you can ask. See, for me, it will take time to put all this on the paper. So that is why certain things I am not able to put. So in the flags, if you are seeing on the page number 230 or 231, their flags, higher byte is there and lower byte is there. Then individual each bits, what it is doing, that is also given in one of the pages. Anything more you want to find out from me, you can ask.
Ma'am,
Then,
flag registers, these all flag registers we supposed to write from status
yes,
flag to interrupt flag.
yes.
Okay, okay. Advantages of using segment registers also, this is the complete answer, ma'am.
About the
But till
segment register.
director flag we supposed to stop, or we should continue this all segment registers. This is a different one, right? Segment register.
Yes. Segment registers are only ES, CS, SS, and DS. IP
Yes,
is your instruction pointer. So you should not write anything about IP when you are talking about the segment registers. What are segment registers? What is the length of the segment register? What work it does? You have to cover this many points when you are discussing about the segment registers.
register. Okay, thank you.
Now, next one is generating physical memory address. So that. Then next important topic would be what will be the addressing modes and instructions. That we can discuss in the next class because it will be again a big topic. So you can expect one or two long questions. Yes.
Ma'am, good afternoon, ma'am.
Yes.
Send this PDF in the group, ma'am.
Okay. This no. some, like you can see on the screen also, the first page, to highlight only that block diagram, it is taken half. Again, it is repeated. I have to scan it once again and I will send, because this is not very proper here. So you have to, by night today, I will scan it once again and then I will send, because it is not in a proper order which has come here.
Okay, ma'am. Thank you, ma'am.
But is it useful or otherwise? Otherwise, you can see here, if you are finding something like the material here will be little more. So in your textbook, I have seen at times it is very brief and then to the point. So if you are able to read this, but you can prepare for your exam from your material. So that, because in exam you will not have time to write what all is being discussed here in the class. So you have to plan to write your answers, especially the long answers, such that that much time is sufficient for you to cover the points which you are thinking
All questions.
are important. There you have to, since you have to maintain the time, you have to adjust the time such that that answer will be completed in that much of time. So although this, because you are not writing for the first time, but still you have to plan how much you have to write in the exam.
Okay, ma'am.
So next one we will deal up with the, and one more thing I wanted to tell is, in the pin diagram, I will put the pin diagram, and again, since address bus, data bus, all these will have one pins, and then the control bus or the control signals. So what is new in that much only we will discuss in the class about the pin diagram. Anything more if you want, you can ask. Because for today, I thought architecture will take long time, but it has not taken so much of time as
Ma'am,
we thought.
one doubt, ma'am.
Yes, yes.
In the examination, they ask pin configuration of 8086 microprocessor. That's time only you have to draw the pin configuration in the
Yes,
page
yes,
number
yes. See,
254.
I will, you can also see in your material, you see how the pin diagram is. I will.
Pin diagram not given in.
No, 85 you see, you will understand.
Oh, okay, ma'am.
So you have to put that 40 pin diagram and you have to discuss about each pin there. So like this, about each pin you have to write some 2 to 3 lines. So that pin diagram is also a long question only. They will ask only one. Either they will ask you the architecture or a block diagram, or they will ask you the pin diagram. They will never ask you both of them together. Whichever processor it is, whether it is 8085 or 8086. If you people can get some old question papers, then you will get an idea about how the questions are asked. You try to get those so that you can also think to answer in that lines also. Those are available, but now I am not having. I would have given you, but I am not having. So you try to get from your friends so that some of you can post it in the group, and then it will be useful for everybody. So programming is not there, only some instructions are there, and what are the different addressing modes. Same thing, you had instructions and addressing modes in 8085 also. I hope you remember those things. Immediate addressing mode, register addressing mode.
Yes, ma'am.
So here also you are having some addressing modes and then some instructions. But I have not seen any instructions question being asked in the exam on 8086 as much as I remember. But addressing modes you have to understand. So by next class 8086 we can finish off the discussion. Okay. So can I stop now?
Thank you, ma'am.
Okay, thank you.
Thank you so much, ma'am.
Thank you, ma'am.
By today night, I will send this PDF because I have to scan it once again. Okay.
Okay, ma'am. Okay,
ma'am.
ma'am.
Thank you, ma'am.
So thank you all.
Thank you.